Hi, I am Andres Felipe Muñoz, a civil engineer from Colombia, a country in South America, and with this video I'm presenting my final project for CS50 Introduction to Programming with Python. As a civil engineer who works in design steel and concrete structures, I've been looking for ways to optimize and improve my work methodologies for more efficient ones, like with the use of algorithms that automatize parts of my work or help me reach an acceptable conclusion in less time. As the first step for that goal, I made this simple program that can help with the process of designing steel for concrete beams by showing a set of combination of bars that fit a certain area required by calculation, either being done by hand or with the help of ETABS, a commercial calculation and design software for structural analysis used worldwide. The script that I wrote was made entirely in Python, using the knowledge acquired in the course and some other books. With that being said, I'm going to turn a little bit of its use. Alright, let's gonna start this quick demonstration launching the script right in Python and project.py. The menu presenter here brings three options for the user descending in order of complexity, the first one being bar selection for given area. This option was designed to be the fastest and simplest method to present the user with a result, using the fewest number of steps and with the least amount of information required. It's ideal for quick verification or queries. Let's gonna set up some simple values to the variables, and there you have it. The result obtained is a table of all possible combinations in number of bars, considering a difference of two diameters. It tabulates the configuration, the total number of bars, the steel area involved, the weight within the distribution equation, and the width of the beam in centimeters needed to accommodate the solution. Launching again the script, let's gonna choose the second option now, bar selection for given area and beam width. This is like the first option, however with the difference that this one asks the user for additional information, like beam width, beam cover, and shear bar diameter. In the same way as the previous method, all variables except the steel area have a default value activated by an empty field in the input of the information. This option was designed so that the solution can be adapted to a beam with a given width, and is the second fastest option of the program, being able to make punctual verification for a specific beam dimension. Now launching the script for the third and final time, we have calculate rebar from file. This is the most complex design and relatively automatic option of the script, but also the one that requires the most configuration and consideration by the user. It requests the name of the file containing the reinforcement information necessary in the beam generated by the ETABS calculation program. Let's gonna use an example that I already have here. The table will serve as a data source to calculate the combinations that apply for each position within the beam, which is immediately requested in an infinite loop. This table will serve as data source to calculate the combinations that apply for each position within the beam, which is immediately requested in an infinite loop, where the next section to be verified is asked each time, until the user finishes the program by closing it or by pressing the key combination Ctrl+C. For example, and let's gonna choose the first position, and now the second, the third, and so on. It should be clarified that in the case of this option, the plausible combination for the top and bottom reinforcement of the beam for the requested position are given. Finally, it must be said that this tool, represented here, was designed to assist in the development of an otherwise manually laborious and intensive task, but automatic as much as possible within the initial scope. That said, this program is only the starting point for the solution, with basic functionalities that can be used and adapted within a more complex and complete tools that automate the entire process, using iterative analysis and optimizations with, for example, the use of a neural network. Thank you for your attention, and I hope this presentation has been interesting for you. Until the next time.